Все, пошел по точке. Сейчас будем, короче, смотреть, ну, PS5. Она выйдет уже прям вот сейчас уже, да. Ну, не выйдет, а только ее объявят, там, характеристики, все вот это вот. Ага, так. Мне вот интересно, да? Почему у меня опять выключен чат, да? Да? Я угадал? Нет, не угадал. Не знаю, у меня, по-моему, чат выключен. Господи, почему? Ой, это не то. А, нет, чат есть. Все офигенно. Офигенно все, да? О, сейчас задержки нет. Офигенно. Все, по-моему, вообще по красоте. Так. Так. Ладно, все, в принципе, я подумаю. Вот это вот тоже. Все. Так, вот тут она уже через 7 минут начнется, в принципе. Кстати, пока чат почекаем, что-то у нас ничего. Ладно, сейчас я тогда одену масочку свою, наверное, как обычно, и от коронавируса, защита от коронавируса, да. Дук заразно PlayStation коронавирусом. Так, сейчас. Не знаю, будет ли это нормально, либо не будет. Так. О, все, вот пошло. Только сейчас нужно будет кое-что. Ну да, мы немного ее уменьшим. Да, вот так вот оставим. Все. Захват экрана. Кстати, мой рабочий стол, как вам он? Да, у меня iMac. Все, пошло. О, смотрите, сколько пошло людей. Ой. Так. Где телефон-то мой? PlayStation 5 ждут, наверное, миллионы людей, потому что, все же говорится, консоль, получается, 5-го поколения уже. Вот. По слухам, она должна быть... Точнее, она должна быть менее мощной, чем Xbox серии X, потому что такое, что там типа 12 терабайтов будет. Там, короче, будет все топово, начинка прям, ну я не знаю, может сейчас ее объявят, и может она будет, конечно, лучше. Я не удивлюсь реально, если PlayStation будет намного лучше, чем все остальные, потому что на нее выходит, во-первых, больше эксклюзивов. Детройда на нем нету, я помню. Ну, как я должен знать, вроде нет Детройда на нем. Вот, так что... Как-то так. Так что как-то вот так. Вот, да. Мистер Ванек, да, нормально, хорошо. Сейчас будем смотреть новый PlayStation. 4 минутки осталось. 4 вот 4 минуты осталось. Так что сейчас мы ее посмотрим. Она должна быть, наверное, я не знаю, как она вообще будет по характеристикам. Помню. напомню тебе. Ванек. Что тебе не нравится? Кстати, у меня iMac. Вот iMac, видите, вот тут все есть. Вот iMac. Вот видите, iMac даже у меня. Да. iMac целый. Да я знаю, что ты Ванек, я помню тебя. Алло. Рыбкин. А, нет, я тебя не помню. Ладно, шутка. 3 минуты на часах. Ну да, как раз 3 минуты. Я думал, ты обрадуешься. Да я обрадовался, да. Прикольно. Офигенно. Вот так вот. Кстати, что там, подождите. Как там идет? Вообще задержки нет. Офигеть. Это просто вот. Это офигенно. Это просто офигенно. Ну ладно, я буду так смотреть, наверное, как-то стоям. Что-то у нас близко-то. Все, вот так вот смотреть буду. Так. 2 минуты, кстати, осталось. Это уже нравится мне. 2 минуты, кстати, осталось. Это уже нравится. Господи, почему? Как же ненавижу, когда я свой голос слышу. Почему? Да я не знаю. 60 секунд. Офигенно. Чат я и что вижу. Блин, как же я хочу себе второй мотор, господи. На этом играть невозможно. Что там? Кстати, мне скоро комп починит. Офигенно, ждем. То без тебя скучно играть в КС, прям вообще скучно. Только, правда, ты это, по-моему, ты месяц говорил назад. Ну ладно, я не буду ничего говорить. Сколько? Кстати, подожди. Нет. О. Вот, все. Блин, минута еще осталось. Фак. Получается, минута же. Да, минута, по сути, должна остаться. А почему писал, что 60 секунд? Я это хотел новый ПК купить. Ты хотел Харпер ПК. Хайпер ПК. Хайпер PC компанию купить? Ну, комп у них, а не саму компанию купить, потому что это будет очень дорого. Я так понял? Ну, да, я понял, про что ты имеешь в виду. Ну, их компы там по 50, что ли, что-то такое тысяч стоит. Сорок 49, 50, 51. Тем более. Ой. Все. 19:00. Начинается. Давайте. Ну, буду обновлять вот так вот. О, пошло. Это прям премьера, я думаю, прямая трансляция будет. Это было прикольно немного. Ау. Так. Тогда я себя немного поменьше сделаю, то вебка, не лагай. Вебка лагает или мне? Ну лагает, это пипец, что за фигня? Ее менять буду нахрен. Это защита от коронавируса, кстати. Окей. Не, все нормально. Господи, по-моему, орёт слишком уж сильно. Хотя хз нормально вроде. Ну, пока это нахрен вырубили, неприятный звук, прям вообще невозможно смотреть даже. Так. Не знаю, конечно, сейчас там, скорее всего, будет на английском, но это пипец, это реально будет капец, это будет сейчас прям вообще жопа, потому что я... О! Пошло, поехало. 3, 2, 1. Дизайн, покажите дизайн. Ну тут прям святой дизайн. Так, здравствуйте, я Джим Райан, президент PS5, что ли? Мы создали что-то там новую консоль, которая будет PS5. Будет максимум сильнее. Что говорю? Перевернет игру PlayStation 5. Что там? Вот PlayStation 2, PlayStation 3. Типа история консоли и дизайны. Дизайн консоли был новый. Занимались наши лучшие дизайнеры. PlayStation 3.
So, starting with PlayStation 4, we've taken a different approach, roughly centered around 3 consoles. The first of these is listening to the developers, which is to say that a lot of what we put into a console derives directly from the needs and aspirations of the game creators. We definitely do have some ideas of our own, but at the core of our philosophy for designing consoles is that game players are here for fantastic games.
Удобное, чтобы играть, скорее всего.
Anything we can do to make life easier for the game creators or help them realize their dreams, we will do.
Что?
About once every 2 years, I take a tour of the industry. I go to the various developers and publishers, sit down and discuss
сколько консолей вообще в мире это пишется или как? Так.
This requires weeks on the road, as reaching the bulk of the game creators involves talking to well over something like 24 publishers.
Ну, скорее всего, да, сколько здесь вообще PlayStation получается.
By the way, the feature most requested by the developers, that was an SSD, which we were very happy to put in the hardware, but a lot of problem solving was required. I'll be doing a deep dive on the SSD and surrounding systems later on in this talk. It's also key to make a generational
Да, вот революция консоли от PlayStation 1, PlayStation 2 и PlayStation 3. Четвертый не показали, я не понял. Все-таки.
Now, with PlayStation 1, 2, and 3, the target was a revolution each time with a brand new feature set. That was great in many ways, but time for the developers to get up and running got longer with each console. In the past, I've called this time to triangle. Here's what I had for those 3 consoles. To be clear, I'm not talking about time to make a game. Developers will be ambitious, and it may take 6 years or so to realize their vision. What I'm talking about is that dead time before graphics and other aspects of game development are up and running.
Сколько они разрабатывали консоль, наверное.
On the other hand, if we're trying to reduce that dead time to 0, that means the hardware architecture can't change at all. We're handcuffed. We need to judge for each feature what value it adds and whether it's worth the increase in developer time needed to support it. So with PlayStation 4, we were able to strike a pretty good balance between performance and familiarity. We got required learning back to PlayStation 1 levels. With PS5, the GPU was definitely the area we felt the most tension between adding new features and keeping a familiar programming model. Ultimately, I think we've ended up with
пока ничего, они вообще не показывают консоль. Они вообще не показывают дизайн, чтобы, как говорится, не спойлерить.
I'll go into a bit more detail later today about our philosophy with the GPU and the specific feature set that resulted from it. It's also very important for us, as the hardware team, to find new dreams, by which I mean something other than CPU performance, GPU performance, and the amount of RAM. The increase in graphics performance over the past 2 decades has been astonishing, but there are other areas in which we can innovate and provide significant value to the game creators, and through them, the players. That's why the SSD was very much on our list of directions to explore, regardless of what came out of the conversations with game developers and publishers. The biggest feature in this category is the custom engine for audio. That's today's
Кастомная
final
система.
topic. The push for vastly improved
Что-то...
audio. And
Я
innovative
понял.
3D audio isn't something that came out of the developer meetings. It's much more the case that we had a dream of what might be possible 5
My
years from
people.
now, and then worked out a number of steps we could take to set us on that path.
Давай дизайн покажите, покажи
So here again are
дизайн.
the 3 principles. The first being
Так,
enabling the desires of developers to drive the hardware design. To me, the SSD really is the leader in
SSD.
this generation.
Скорее всего, будет
It's
мощный
an engine,
процессор.
and it was the
Наверное, будет
number
9
one ask
терабайт
of
в памяти, как говорят. И...
As in,
Что там
we
еще
know
должно
it's
быть?
probably impossible, but can you put an SSD in it? That was a discussion we were also having internally. It was clear that the presence of a hard drive in every PlayStation 4 was having a positive impact. A lot of things that would simply have been impossible at Blu-ray disc speeds were now possible. At the same time, though, in 2015 and 2016, when we were having these conversations, developers were already banging up against the limits of the hard drive, and a lot of developer time was being spent designing around slow load speeds. I want to focus in on just one number here, which is how long it takes to load a gigabyte of data from a hard drive. The difficulty being that hard drives are
Так,
not very fast nor flexible. If all your data is in one
10
block,
мегабайт в
which is
секунду,
frankly
100
not very
мегабайт в
likely,
секунду.
you can load 50 to 100
Передавание
megabytes a second,
файлов?
depending on where your
Да,
data is located
да,
on the hard drive.
передаваемый
Let's
файл
assume it's on
для
the outer edge, which means loading a
1
gigabyte
гигабайт
every 7 seconds. If you
10
compress your data
секунд.
packages, you can fit more data on the Blu-ray disc and also effectively boost your hard drive read speed and compression ratio. We support zlib decompression
Типа из-за того, что они будут
that gets you
графика,
something like
они...
50% more data on the disk and 50% higher effective read speed. Unfortunately, though, it's highly likely that your data is scattered
Что?
around in various files on the hard drive, as well as sourced from multiple locations within those files. So lots of seeks are needed at 2 to
типа...
50-ish milliseconds each. My rule of thumb is that the hard drive is spending 2/3 of its time seeking, and only 1/3 of its time actually loading data. Putting all of that together, a gigabyte is very roughly 20 seconds to load from a hard
Ты
drive.
понимаешь, 1 гигабайт передаваться за
Now,
20
a
секунд?
gigabyte is not much data.
При
Games are
скорости
using 5 or
100.
6 gigabytes of RAM on PlayStation 4, so boot times and load times can get pretty grim. Or to put that differently, as a player, you wait for the game to boot, wait for the game to load, wait for the level to reload every time you die, and you wait for what is euphemistically called fast travel. And all of that leads to the dream. What if we could have not just an SSD,
Так,
but a blindingly fast SSD? If we could load 5 gigabytes a second from it, what would change? Now, SSDs are completely
ну,
different
в
from hard drives.
принципе...
They don't have seeks as such. If you have a 5 gigabyte a second SSD, you can read data from 1,000 different locations in that second, pretty much at speed. As for time to load a gigabyte, this is next gen we're talking about, so millions bigger. Instead, we should be asking how long to load 2 gigabytes. And the answer is about a quarter of a
2
second.
гигабайта...
And it's amazing.
Вообще 2
We're talking
гигабайта будут
2
задаваться
orders of
за
magnitude,
практически 0
meaning
секунд.
very roughly 100 times faster. Which means at 5 gigabytes a second,
Это
the SSD
PS5.
potential is that
А там было
in
PS4.
a second, there are no load screens. The game just fades down while loading a half dozen gigabytes and fades back up again. Same for a reload. You're immediately back in the action after you die. And fast travel becomes so fast it's blink and you miss it. As
Чтобы сотрудники сидят здесь, короче, типа смотрят. Чтобы это людей лишних не звать, типа. Зачем это надо?
To being so blindingly fast that we might even have to slow that transition down. Pretty cool, right? But for me, this is not the primary reason to change from a hard drive to an SSD.
Дизайн консоли, давайте все вот гадать, что будет.
Gives the game designer freedom. Or to put that differently, with a hard drive, the 20 seconds that it takes to load a gigabyte can sabotage the game that the developer is trying to create. I think almost all of us in the room have experienced this, maybe
Так, что?
in different ways. Say we're making an adventure game and we have two rich environments where we each want enough textures and models to fill memory, which you can do as long as you have a long staircase or elevator ride or a windy corridor where you can ditch the old assets and then take 30 seconds or so to load the new assets. Having a 30-second elevator ride is a little extreme. More realistically, we'd probably chop the world into a number of smaller pieces and then do some calculations with sight lines and run speeds like we did for Haven City when we were making Jack 2. The game is
Что
20 years
это
old, but
какая-то
not
игра?
much has changed
Должно
since
быть,
then.
да.
All those twisty passages are there for a reason. There's a whole subset of level design dedicated to this sort of work, but still, it's a giant distraction for a team that just wants to make their game. So when I talked about the dream of an SSD, part of the reason for that 5
О,
gigabyte a second target was the way
стриминг.
it loads, but
Типа
also part of the
стримы
reason for that target was streaming. As in,
подключенному.
what if the SSD is so fast that as the player is turning around, it's possible to load
Нет.
textures for everything behind the player in that split second? If you figure that
Привет,
it
меня в
takes
Steam
half a second to
взломали.
turn, that's
Да.
4 gigabytes of compressed data you can load. That sounds about
Товарищ,
right.
что сделали? Зачем так делать-то?
Anyway, back to the hard drive. Another strategy for increasing effective read speed is
Плохо,
to make big
плохо.
sequential chunks of data. For example, we might group all the data together for each city block. That removes most of the seeks. And the streaming gets
Я ни
better,
хера не понимаю,
but
что он
there's a
говорит, но это
downside,
интересно.
which is that frequently used data is included in many chunks and therefore is on the hard drive many, many times. Marvel's Spider-Man uses this strategy, and though it works very well for
Marvel
increasing the
Spider-Man?
streaming speed, there's a
Что,
massive
типа...
duplication as a result. Some of the objects like mailboxes or news racks are on the hard drive 400 times. What I'm describing here are things that cramp a creative director's style. Either level design gets a little bit boring in places, or the data is duplicated so many times that it no longer fits on the Blu-ray disc. And you end up with hard limits on the player's run speed or driving speed. The player can't go faster than the load speed from the hard drive. And finally, I'm sure many of you have noticed that after a patch download, a PlayStation 4 will sometimes take a long time to install the patch. That's because when just part of a file has been changed, the new data can be downloaded pretty quickly. But before the game boots up, a brand new file has to be constructed that includes the changed portion. Otherwise, every change would add a seek or two. Even so, you can occasionally see this happening on game titles. They start to hitch once they get patched enough. With an SSD, though, no seeks, so no need to make brand new files with the changes incorporated into them, which means no installs as you know them today. There's yet one more benefit, which is that system memory can be used much more efficiently.
Память
On
8
PlayStation 4, game
гигабайтов
data
всего
on the hard
лишь.
drive feels very distant and difficult to use. By the time you realize you need a piece of data, it's much too late to go out and load it. So system memory has to contain all of the data that can be used in the next
Типа
30
все будет
seconds.
загружаться за 30 секунд.
That means a lot of the 8 gigabytes of system memory is idle. It's just waiting there to be potentially used. On PlayStation 5, though, the SSD is very close to being like
Это было
RAM.
4, а
Basically, it's
это
fast
5,
enough
то
that
есть
when you
сейчас они
realize you
16
need a piece of data,
гигабайтов.
you can just load it from the SSD and use it. There's
Далеко
no
не
need
ушли.
to have lots of data parked in system memory waiting to potentially be used. A different way of saying that is that most of RAM is working on the game's behalf. This is one of the reasons that 16 gigabytes of GDDR6 feels right for PlayStation 5. The presence of the SSD reduces the need for a massive intergenerational increase in size. So back to the dream of the SSD. Here's the set of targets. Boot the game in a second. No load screens. Design free, meaning no twisty passages or long corridors. More game on the disk and more game on the SSD. And finally, those patch installs go away. The reality, though, is that the SSD is just one piece of the puzzle. There's a lot of places where bottlenecks can occur in between the SSD and the game code that uses the data. You can see this on PlayStation 4. If I use an SSD that's 10 times the speed of a standard hard drive, I probably see only double the loading speed, if that. For PlayStation 5, Our goal was not just that the SSD itself be 100 times faster. It was that game loads
А
and
теперь
streaming would be
пятое.
100 times faster. So every single potential bottleneck needed to be the loading speed. The loading, thus that the SSD itself be 100 times faster. It was that game loads and streaming would be 100 times faster. So every single potential
Сколько смотрит?
bottleneck
15
needed
минут,
to be addressed.
пипец.
And there are a lot of them.
Они до сих пор не показали
Let's look
новый
at
дизайн.
check-in and what happens when its overhead gets 100 times larger. Conceptually, check-in is a pretty simple process. Data is loaded into system memory from the hard drive or SSD.
Так,
It's examined.
система.
A few values are tweaked to check it in, and then it's moved to its final location. At the SSD speeds we're talking about, that last part, moving the data, meaning copying it from one location to another, takes roughly an entire next-gen CPU core. And that's just the tip of the iceberg. If all the overheads get 100 times larger, that will cripple the frame rate as soon as the player moves, and that massive stream of data starts coming off the SSD. So to solve all of that, we built a lot of custom
Кастомный
hardware,
контроллер,
a custom
флешка.
flash controller, and a number of
Кастомный
custom
быстрый
units
контроллер.
on the chip. The flash controller in the SSD was designed for smooth and bottleneck-free operation, but also with games in mind. For example, there are 6 levels of priority when reading from the SSD. Priority is very important. You can imagine the player heading into some new location in the world and the game requesting 50 gigabytes of textures. And while those textures are being loaded, an enemy is shot and has to speak a few dying words. Having multiple priority levels lets the audio for those dying words get loaded immediately. On one side, that flash controller connects to the actual flash dies that supply the storage. To reach our bandwidth target of 5 gigabytes a second, we ended up with a 12-channel interface. 8 channels wouldn't be enough. The resulting bandwidth we've achieved is actually 5.5 gigabytes a second. With a 12-channel interface, the most natural size that emerges for an SSD is 825 gigabytes. The key question for us was, is that enough? I mean, it's tempting to add more, but Flash certainly doesn't come cheap, and we have a responsibility to our gaming audience to be cost-effective with regards to what we put in the console. Ultimately, we resolved this question by looking at the play patterns of a broad range of gamers. We examined the specific games that they were playing over the course of a weekend or a week or a month, and whether that set of games would fit properly on the SSD. We were able to establish that the friction caused by reinstalls or redownloads would be quite low, and so we locked in on that 825 gigabyte size, while also preparing multiple strategies so that those who want more storage can add it. I'll go through the details in a moment. Back to the flash controller. On the other side, it connects to our main custom chip via 4 lanes of Gen 4 PCIe. And inside the main custom chip is a pretty hefty unit dedicated to I/O. Before we talk about what that does, let's talk compression for a moment. PlayStation 4 used zlib as its compression format. We decided to use it again on PlayStation 5. On my 2017 tour of developers, I learned about a new format called Kraken from Rad Game Tools. It's like zlib's smarter cousin. Simple, similar types of algorithms, but about 10% better compression, which is pretty big. That means 10% more game on the UHD Blu-ray disc or on the SSD. Kraken had only been out for a year, but it was already becoming a
сесть.
standard. Half of the teams I talked to were either using it or getting ready to evaluate it. So we hustled and built a custom decompressor into the I/O unit, one capable of handling over 5 gigabytes of Kraken format input data a second. After decompression, that typically becomes 8 or 9 gigabytes, but the unit itself is capable of outputting as much as 20
Причем здесь
gigabytes a
сейчас
second
минок,
if
то
the
есть
data
этот
happened to compress particularly well. By the way, in terms of performance, that custom decompressor equates to 9 of our Zen 2 cores.
кастомный чип у них будет получается.
With the conventional CPU. There's a lot more in the custom I/O unit, including a dedicated DMA controller. The game can direct exactly where it wants to send the data coming off of the SSD. This equates to another Zen 2 core or 2 in terms of its copy performance. Its primary purpose is to remove check-in as a bottleneck. There's 2 dedicated I/O coprocessors and a large RAM pool. These aren't Zen 2 cores. They're there principally to direct the variety of custom hardware around them. One of the coprocessors is dedicated to SSD I/O. This lets us bypass traditional file I/O and its bottlenecks when reading from the SSD. The other is responsible for memory mapping, which I know doesn't sound like anything related to the SSD, but a lot of developers map and remap memory as part of file I/O, and this too can become a bottleneck. There are coherency engines to assist the coprocessors. Coherency comes up a lot in places. Probably the biggest coherency issue is stale data in the GPU caches. Flushing all of the GPU caches whenever the SSD is read is an unattractive option. It could really hurt the GPU performance. So we've implemented a gentler way of doing things, where the coherency engines inform the GPU of the overwritten address ranges, and custom scrubbers in several dozen GPU caches do pinpoint evictions of just those address ranges. The best thing is, as a game developer, when you read from the SSD, you don't need to know any of this. You don't even need to manage
Секунду,
the
кстати,
data
уже.
that's compressed. You just indicate what data you'd like to read from your original uncompressed file and where you'd like to put it, and the whole process
Можно
of
сказать,
loading
неплохо.
it happens invisibly to you and at very high speed. Back to the dream.
Так.
Thanks to all of that surrounding hardware,
Вот это
our
SSD опять
5.5
все. Типа
gigabytes a
5
second really
гигабайт в
should translate into
секунду.
something like
Передача
100
файлов.
times
Что
faster
это?
than PS4, and allow the dream of no
Ну, скорее всего, вот это вот уже, да, скорее всего, вот это уже передача идет. Это что такое было?
Having said that, expandability of our SSD is going to be quite important. Flash is costly, and you may very well want to add storage to whatever we put in the console. Now, the kind of storage you need depends on how you're going to use it. If you have an extensive PlayStation 4 library and you'd like to take advantage of backwards compatibility to play those games on PlayStation 5, then a large external hard drive is ideal. You can leave your games on the hard drive and play them directly from there, thus saving the pricier SSD storage for your PlayStation 5 titles.
Я
Or
раньше не
you can
понимал,
copy your
господи,
active
почему так все
PlayStation 4
сложно?
titles to the SSD. If your purpose in adding more storage is to play PlayStation 5 titles, though, ideally you would add it to your SSD storage.
Блин, что
We will
это?
be supporting certain M2 SSDs. These are internal drives that you can get on the
Спасибо тебе, братишка, спасибо. Нет, не опоздал, все нормально.
As for which ones we support and when, I'll get to that in a moment. They connect through the custom
Как это выглядело на
that
стриме?
our SSD does, so they can take full advantage of the decompression.
Сигнал рисовать.
All
Нет,
the
это
other
уже
features
нет, это уже
that
бывает лишнее.
Here's the catch,
Я
though.
так думал.
That commercial drive has to be at least as fast as ours. Games that rely on the speed of our SSD need to work flawlessly with an M2 drive. When I gave the Wired interview last year, I said that the PlayStation 5
Мой, наверное,
SSD
донат
was faster
за
than
столько
anything
времени.
available on PC. At the time, commercial M2 drives used PCIe 3.0, and 4 lanes of that cap out at 3.5 gigabytes a second. In other words, no PCIe 3.0 drive can hit the required spec. M2 drives with PCIe 4.0 are now out in the market. We're getting our samples and seeing 4 or 5 gigabytes a second for them. By year's end, I expect there will be drives that saturate 4.0 and support 7 gigabytes a second. Having said that, we are comparing apples and oranges, though, because that commercial M2 drive will have its own architecture, its own flash controller, and so on. For example, the NVMe specification
Ожидал
lays out
больше.
priority
В смысле
schemes
больше
that the
ожидал.
M2 drives can use. And that scheme
Раз на донат, это не канал Зерновка.
Our drive supports 6. We can
Или от чего ты
hook
ожидал
up a
больше? Типа от
drive to
консоли
the
или
memory
от
level,
чего?
definitely, but our custom I/O unit has to arbitrate the extra priorities rather than the M2 drive's flash controller, and so the M2 drive needs a little extra speed to take care of issues arising
О.
from a different approach.
Блин, она это закрывать не надо, ну ладно.
Inside of the bay we
Пофиг.
created in PlayStation 5 for M2 drives. Unlike internal hard drives, there's unfortunately no standard for the height of an M2 drive, and some M2 drives have giant heat sinks. In fact, some of them even have their own fans. Right now, we're getting M2 drive samples and benchmarking them in various ways. When games hit beta as they get ready for the PlayStation 5 launch at year-end, we'll also be doing some compatibility testing to make sure that the architecture of particular M2 drives isn't too foreign for the games to handle. Once we've done that compatibility testing, we should be able to start letting you know which drives will physically fit and which drive samples are benchmarked appropriately high in our testing.
Спина
It
боль.
would be great if that happened by March, but it's likely to be a bit past it. So please hold off on getting that M2 drive Back to our principles. Balancing evolution and revolution is the second of them. This was
Revolution,
definitely
revolution,
the third
revolution.
theme with the GPU. We need new GPU features and capabilities. If we only have more performance, it's not really a new generation of console. Of course, many of these
Что-то вообще там
capabilities
происходит,
result
дайте
from
посмотреть.
performance. That's part of why a PlayStation 5
Спид,
console
по-моему,
is
но это
powerful
никому не
and
интересно,
still
типа.
take flight. But we aren't just
Всем
looking for
интересно, какая
performance. We
будет
also
именно...
need the ability to do something with the GPU that could
Нихера
not
себе,
be done
смотрите.
before. And we need higher performance per watt.
Жестко.
Every time we double the performance of some GPU
По-любому сейчас
core,
100к будет.
we don't want to find out how
Больше
fast
полумиллиона человек смотрит. Ни хрена себе.
But at the same time, we have to make
Больше
sure
полуляма
the
смотрит.
GPU
Ё-моё.
guarantees 4 games,
Чё
and we have to
такое-то?
ensure that the architecture is easy
Как
for the
так-то?
developers to adopt. Now, backwards compatibility was handled masterfully by AMD. They treated it as a key need throughout the design process. As our solution to adding new features without blindsiding developers, we made sure that if there were new significant features, it would be optional to use them. The GPU supports ray tracing, but you don't have to use ray tracing to make your game. The GPU supports primitive shaders, but you can release your first game on PlayStation 5 without making any use of them. Before I get into the capabilities of the GPU, I'd like to make clear 2 points that can be quite confusing. First, we have a custom AMD GPU based on their RDNA 2
У
technology.
них AMD процессор
continuously
будет.
improving and revising their tech. For
Это, конечно, такой себе. Не,
their
по-моему,
goal
кстати, AMD, они как
roughly
больше для графики
to
сделаны. Или
reduce
Intel.
power consumption
Я
by
не точно
re-architecting
не знаю, но,
CPU
по-моему,
data close to where it's
AMD будет немного
to
похуже, чем Intel.
optimize the GPU for performance and to add a new, more advanced
А
feature.
что, там они вроде одинаково уже
But that
становятся
feature
как-то.
set is malleable, which is to say that we have our own needs for
Ну, потом, кстати,
customization, and
глянем,
that can factor into
когда
everything.
на русском все это выйдет, мы потом еще будем, мы еще глянем
Collaboration is born.
PlayStation 4, сравним
When
ее
concepts to AMD
с
were
PS5.
felt to be widely useful, then they can be adopted into RDNA 2 and used broadly, including in PC GPUs. If the ideas are sufficiently specific to what we're trying to accomplish, like the GPU cache scrubbers I was talking about, then they end up being just for us. If you see
Просто я же даже еще немного болею сейчас, чуть-чуть прям так
available
вот,
as
молюсь,
a
наконец
PC
такое.
card at roughly the same time as we release our console, that means our collaboration with AMD
Коллаборация с...
in producing technology useful in both
Коллаборация с
worlds.
кем?
It doesn't mean that we as Sony simply incorporated the PC part
Simple?
into our console.
Коллаборация с
This
Simple?
continuous improvement in AMD
Офигеть, конечно,
technology
не...
means it's dangerous to rely on teraflops as an absolute indicator of performance, and CU count should be avoided as well. In the case of CPUs, we all understand this. The PlayStation 4 and PlayStation 5 each have 8 CPUs, but we never think that meant the capabilities and performance are equal. It's the same for CPUs. For one thing, they've been getting much larger over time. Adding new features means adding lots of transistors. In fact, the transistor count for a PlayStation 5 CU is 62% larger than the transistor count for a PlayStation 4 CU. Second, the PlayStation 5 GPU is backwards compatible with PlayStation 4. What does that mean? One way you can achieve backwards compatibility is to put the previous console's chipset in the new console, like we did with some PlayStation 3s.
Chipset
But that's,
как
of course,
PS3 получается?
extremely expensive.
Или как
Another
это?
way is to incorporate any differences in the previous console's logic into the new console's custom chips, meaning that even as the technology evolves, the logic and feature set that PlayStation 4 and PlayStation 4 Pro titles rely on is still available in backwards compatibility modes. One advantage of this strategy is that once backwards compatibility is in the console, it's in. It's not as if a cost down will remove backwards compatibility like it did on PlayStation 3. Achieving this
PlayStation 3?
unification of functionality took
Что?
years of efforts by AMD, as any roadmap advancement creates a potential divergence in logic. Running PS4 and PS4 titles at boosted frequencies has also added complexity. The boost is truly noticeable this time around, and some game code just can't handle it. Testing has to be done on a title-by-title basis. Results are excellent, though. We recently took a look at the top 100 PlayStation 4 titles ranked by playtime, and we're expecting almost all of them to be playable at launch on PlayStation. With regards to new features, as I said, our strategy was to try to break new ground, but at the same time not to require use of the new GPU capability. For more than a decade, GPUs have imposed a restriction on game engines. Software handles vertex processing, but for the most part, dedicated hardware is responsible for the triangles and other geometry that the vertices form. That means it's not possible to do even basic optimizations, such as aborting processing of a vertex if all geometry that uses it is off-screen. PlayStation 5 has a new unit called the Geometry Engine,
Это
which brings
мозг,
handling of
типа,
triangles and other
геометрический.
primitives under full programmatic control. As a game developer, you're free to ignore its existence and use the PlayStation 5 GPU as if it were no more
Сейчас
capable
какой-то
than
Stalker 2 выйдет на
before it
PlayStation
was
5.
born. Or you can use
Конечно,
this
выйдет.
new intelligence in various ways. Simple usage could be performance optimization, such as removing backfaced or off-screen vertices and triangles. More complex usage involves something called primitive shaders, which allow the game to synthesize geometry on the fly as
Это...
it's being rendered. It's a brand
То
new
есть
feature.
графика. Я так
Using
полагаю,
primitive
шейдеры, это же
shaders in
графика
PlayStation
переводится
5
как?
will allow for a broad variety of techniques, including smoothly varying level of detail, addition of procedural detail to close-up objects, and improvements to particle effects and other visual special effects. Another major new feature of our custom RDNA 2-based GPU is
Трассинг,
ray
трассировка
tracing,
лучей
using the
будет.
same strategy as AMD's
Это я
upcoming
уже что-то
CPU
понимаю,
chip.
хотя хоть трассировка лучей
The
будет.
CUs contain a new
Что лучше
specialized
идет
unit
она,
called the
ё-моё.
intersection engine.
Она мне до
It's
сих пор нормально не
complicated to
показали
integrate
даже.
arrays with boxes and triangles.
Что я
To
ожидаю
use the
это?
intersection engine, first you build what is called an acceleration structure. It's data in RAM that contains all of your geometry.
Так,
There's a
это...
specific set of formats you can use. They're variations on the same BVH concept. Then, in your shader program, you use a new instruction that asks the intersection engine to check array against the BVH. While the intersection engine is processing the requested ray triangle or ray box intersections, the shaders are free to do other work. Having said that, the ray tracing instruction is pretty memory intensive, so it's a good mix with logic heavy. There's of course no need to use ray tracing. PS4 graphics engines will run just fine.
Ну, короче, потом должно быть 3D-звук, если играть с наушниками там. Там, короче, все должно быть повыше на высоте, как у компа за миллион, я думаю. Только это все в консоли, и ты играешь не сидя, хотя там все одно и то же вроде.
Having said that, adding ray-traced shadows and reflections to a traditional graphics engine could easily take hundreds of millions of rays a second, and full
Тени,
ray tracing could take
аудио,
decades. How far can we go? I'm starting to
иллюминации,
get quite bullish. I've already seen a PlayStation 5
рефлекс,
title that's successfully using
трассировка лучей
ray-tracing-based
полная.
reflections in complex animated
То, что
scenes
будет все в
for
консоли,
very
я так и
modest
думаю.
costs. Another set of issues for the GPU involved size and frequency. How big do we make the GPU, and what frequency do we run it at? This is a balancing act. The chip has a cost, and there's a cost for whatever we use
107
to
килолайков
supply that
или
chip with power.
по дела кстати.
In general, I like running the
14.
GPU at higher frequency. Let me show you why. Here's two possible configurations
Так,
for the GPU,
3.6.
roughly at the level of the PlayStation 4 Pro. This is a thought
герцовка.
experiment. Don't take these configurations too
Монитора.
seriously. If you just calculate teraflops,
Телевизор, скорее всего.
but actually the performance is noticeably different because teraflops is defined as the computational capability of the vector ALU. That's just one part of the GPU. There are a lot of other units. And those other units all run faster when the GPU frequency is higher. At 33% higher frequency, rasterization goes 33% faster. Processing the command buffer goes that much faster. The L2 and other caches have that much higher bandwidth, and so on. About the only downside is that system memory is 33% further away in terms of cycles. But the large number of benefits more than counterbalance them. As a friend of mine says, a rising tide lifts all boats. Also, it's easier to fully use 36 CUs in parallel than it is to fully use 48 CUs. When triangles are small, it's much harder to fill all those CUs with useful work. So there's a lot to be said for faster, assuming you can handle the resulting power and heat issues, which frankly, we haven't always done the best job of. Part of the reason for that is, historically, our process for setting CPU
Скоро GTA 6 вроде
has
как-то...
relied on some heavy-duty guesswork with regards to how much electrical power games will consume
это...
and how much heat will be produced as a result inside the console.
Энергия.
Power consumption varies a lot from game to game. When I play God of War on my PS4 Pro, I know the power
Сейчас все углить,
consumption is
короче,
high
будем.
just by the fan noise. But power isn't simply about engine quality. It's about the minutia of what's being displayed and how. It's counterintuitive, but processing dense geometry typically consumes less power than processing simple geometry, which is, I suspect, why Horizon's map screen, with its low triangle count, makes my PS4 Pro heat up so much. Our process on previous consoles has been to try to guess what the maximum power consumption during the entire console,
Потребляемая мощность.
which is to say, the worst case scene in the worst case game, and prepare a cooling solution that we think will be quiet at that
Такого
power level.
такого.
If we get it right, fan noise is minimal. If we
Низший.
get it wrong, the console will be quite
А,
loud
это
for
типа
the
низший
high
уровень, а
and there's
это
even a chance that it
высший
will
уровень.
overheat and shut down if we miss a mistake power.
Как в автомобиле, как у... Я понял.
PlayStation 5 is especially challenging because the CPU supports 256-bit native instructions that consume a lot of power. These are great here and there, but presumably only minimally used. Or are they? If we plan for major 256-bit instruction usage, we need to set the CPU clock substantially lower or noticeably increase the size of the power supply and fan. So, after much discussion, we decided to go with a very different direction on PlayStation 5. We built a GPU with 36 CUs. Mind you, RDNA 2 CUs are large. Each has 62% more transistors than the CUs we were using on PlayStation 4. So, if we compare transistor counts, 36 RDNA 2 CUs equates to roughly 58 PlayStation 4 CUs. It is a fairly sizable GPU. Then we went with a variable frequency strategy for PlayStation 5, which is to say we continuously run the GPU and CPU in boost mode. We supply a generous amount of electrical power and then increase the frequency of GPU and CPU until they reach the capabilities of the system.
Переменная.
It's a completely different paradigm. Rather than running at constant frequency and letting power vary based on the workload, we run at essentially constant power and let the frequency vary based on the workload. We then tackle the engineering
переменная частота.
cost-effective and high-performance
Если можно было понять по картинке.
designed for that specific power level. In some ways, it becomes a simpler problem because there are no more unknowns.
Да, мои знания
No need to
английского меня
guess
всегда
what power
подводят.
consumption the worst-case game might have. As for the details of the cooling solution, we're saving them for our teardown. I think you'll be quite happy with what the engineering team came up with. So, how fast can we run the GPU and CPU with this strategy? The simplest approach would be to look at the actual temperature of the silicon die and throttle the frequency on that basis. But that won't work. It fails to create a consistent PlayStation 5 experience. It wouldn't do to run a console slower simply because it was in a hot room. So rather than look at the actual temperature of the
Кастомный чип
silicon,
опять.
we look at the activities that the GPU and CPU are performing
Короче,
and set the frequencies on that basis, which makes everything deterministic and repeatable. While we're at it, we also use AMD's Smart
Такое
Chip
себе.
technology and send any unused power from the CPU to the GPU so it can squeeze out a few more pixels. The benefits of this strategy are quite large. Running a GPU at 2 gigahertz was looking like an unreachable target with the old fixed frequency strategy. With this new paradigm, we're able to run way over that. In fact, we have to cap the GPU frequency at 2.23 gigahertz so that we guarantee that the on-chip logic operates properly. 36 CUs at 2.23 gigahertz is 10.3
зачем я это сделал?
and we expect the
Я
GPU
не
to
знаю.
spend most of its time at or close to that frequency and performance. Similarly,
Блин,
running
шелк
the
смотри,
CPU
пипец.
at 3 gigahertz was causing headaches with
600
the old
тысяч точнее.
strategy. But now we can run it as high as 3.5 gigahertz. In fact, it spends most of its time at that frequency. That doesn't mean all games will be running at 2.23 gigahertz and 3.5 gigahertz. When that worst-case game arrives, it will run at a lower clock speed, but not too much lower. To reduce power by 10%, it only takes a couple of
Сколько
percent
это уже
less than
идет?
frequency, so I'd expect any
Ну
double
сколько
clock
презентаций-то она на час будет
All
же
things
обычно.
considered, the change to a variable frequency approach will show significant gains for PlayStation gamers. The final of our 3 principles was about finding new dreams. It's important for us on the hardware team to find
Драйвс.
new
А,
ways to
ну
expand and
дизайн.
deepen gaming, and that's what led us to a focus on 3D audio. As players, we experience the game through the visuals, through audio, and through the feedback we receive from the controller, such as rumble or haptics. Personally, I feel a game is just dead without audio. Visuals are, of course, important, but the impact of audio is huge as well. At the same time, the audio team on a game project has to do a lot with a little. For example,
Мечты.
on PlayStation 4, there's fierce
Типа
competition
новые
for
мечты
data rates
игроков.
and cores. Audio typically ends up getting just a fraction of a core. That's not much of a computational resource, particularly when you consider that the visuals run at 30 or 60 frames a second, but audio processing needs to happen at almost 200 times a second. So, it's been tough going making forward progress on audio with PlayStation 4, particularly when PlayStation 3 was such a beast when it came to audio. The
Вот
SPU
процессор уже
itself
сам
was
пошел.
almost a perfect device for audio rendering. Simple pipelined algorithms could really take advantage of asynchronous DNA and frequently reached 100% utilization of the floating point unit. There's unfortunately nothing comparable on PlayStation 4. Probably the most dramatic
Ой,
progress
Вера,
on
поддержка,
PlayStation 4
пипец.
has
Она,
been
кстати, будет или
virtual
нет,
reality.
интересно?
The PSVR hardware has its
Если...
own
Ну
audio
да, она
chip.
будет, скорее всего,
It
тоже.
supports about 50 pretty decent 3D sound sources.
Или они новую
And
будут
this
сделать, или они
provides
новую
a
сделают.
hint as to where we could go with audio, as well as some valuable.
А то VR вышел когда-то в 16 году.
Not to oversimplify,
4 года прошло.
here were our goals for audio on
Господи.
PlayStation 4. The first goal was great audio for everyone, not just VR users or soundbar owners or headphone users. That meant audio had to be part of the console. It couldn't be a peripheral. The second goal was to support hundreds of sound sources. We didn't want developers to have to pick and choose what
новый
sounds would
звук.
get 3D effects and which wouldn't. We wanted every sound in the game to have dimensionality. And finally, we wanted to really take on the challenges of presence and locality. Now, when we say presence, we mean the feeling that you're actually there. You've entered the matrix. It's not, of course, something we thought we could
Сейчас просто у них летит этот
The idea
пипец.
was that if we stopped using just a
Все.
range
Ну,
sound,
кстати, уже
and
начинают
instead
потихоньку
used
них убавляться,
lots of
потому
3D
что
audio sources for rainbow
многим
vision
надоело уже
and
смотреть
all
это.
sorts of locations around you, then at some point your brain would take a leap and you'd begin to have this feeling of a real presence inside the virtual world of the game. This has the capacity to affect your appreciation of the game, just like music in a game does. The concept of locality is simpler. It's just your sense of where the audio is coming from. To the right of you, behind you, above you. This can immerse you further in the game, and it can also directly enhance the gameplay. To use Dead Space as an example, I know, old school.
Ну-ка.
You're fighting enemies in fairly dark, spooky locations.
Реализация.
Back in the
График, да,
day,
именно
if you
сам
played the
походила.
game using the TV speakers, you could tell that there was one last enemy growling and hunting you down, but it was difficult to tell quite where that enemy was. With headphones, you could tell that the enemy was somewhere on the right, which let you deduce, if you couldn't see it, that it must be somewhere behind and to your right. But with 3D audio with good locality, the idea is you know the enemy is precisely there, and you turn and you take it out. So, how do we know where a sound is coming from in the first place? Well, all those bumps and folds in the ear have a meaning, evolutionarily speaking. Based on what direction the sound is coming from, sound waves bounce around inside the ear, there's some constructive and destructive interference, and the result is a change in the phase of the sound also shifts, depending on what path the wave took to reach the ear canal. These volume changes and phase shifts are different for each direction and also vary depending on the frequency of the sound. Head size and head shape impact the sound in a similar fashion. The way that the sound changes based on direction and frequency can be encoded in a table called Head-Related Transfer Function, or HRTF. Here's part of one. The vertical axis is the frequency, the horizontal axis is the direction, front, back, left, right, and the color gives the degree of attenuation of the sound at that frequency. The HRTF is as unique to an individual as a fingerprint is. In fact, you're looking at mine right now. Here's how we measure an HRTF. We've taken hundreds of people through this process.
Это типа где все действия будут выполняться, это... да. Это все вот эти вот игры будут делать, это типа камеры стоят. Как это все будет выглядеть? Ничего себе.
In the course of 10 or 20 minutes, we're able to sample the HRTF at over 1,000 locations. Using an HRTF when rendering audio creates unparalleled quality, but it's computationally expensive. The
Аккумулятор.
simplest way to use an HRTF is to process a sound source to make it appear as if it's coming from one of those 1,000 locations we sample. Unfortunately, the processing has to be done in frequency domain rather than time domain, so there's multiple fast Fourier transforms needed for every sound source for every audio. That's a lot of multiplies. This computational complexity was the determining factor for our strategy. It meant we had to bite the bullet and design and build
О,
a
дизайн
hardware
что-то.
unit for 3D
Что-то про
audio.
дизайн говорит.
Collectively, we're referring to the hardware unit and the proprietary algorithm we have inside of it. In fact, with the Tempest engine, we've even got enough power that we can allocate some
кажется,
to the
пошло.
games, to the extent that games want to make use of convolution reverb and other algorithms that are either computationally expensive or need high bandwidth. But the primary purpose of the Tempest engine remains 3D audio. Now, 3D audio is a major academic research topic. It's safe to say that no one in the world has all of the answers. And the set of algorithms that has to be invented, tuned, or implemented to realize our vision for 3D audio is immense. For example, use of HRTFs in games is quite complex. Before, I talked about making a sound source appear as coming from one of those 1,000 HRTF sample locations. But for high-quality 3D game audio, we have to handle other possibilities. The sound source might not be at one of the 1,000 HRTF sample locations, so we have to blend the HRTF data from the closest location. The sound source might be moving, which needs very special handling as that blend keeps changing, and that can cause phase artifacts in the resulting audio. Or the sound source might have a size to it, meaning it should feel as if it's coming from an area rather than a single point. There's also whole categories of approaches to be handled. 3D audio can be implemented using individual processing of 3D sound sources, but alternatively, ambisonics can be used for 3D audio. Ambisonics being somewhat like the spherical harmonics used in computer graphics. And finally, there's audio devices. The player might be using headphones,
Аудиодевайс, который может подключить.
have a higher-end surround
Ну,
sound
ТВ, конечно же,
all of which need different approaches. That's a lot of variations. It's nice to have the computational resources of the Tempest engine, but it's clear that achieving our ultimate goals with 3D audio is going to be a multi-year, step-by-step process. Having said that, headphone audio implementation is largely complete at this time.
Телефоны, наушники.
It's a natural place for us to start. With headphones, we control exactly what each ear hears, and therefore the algorithmic development and implementation are more straightforward. For TV speakers and stereo speakers, we're in the process of implementing virtual surround sound. The idea being that if you're sitting in a sweet spot in front of the TV, then the sound can be made to feel as if it's coming from any direction, even behind you. Virtual surround sound has a lot in common with 3D audio on headphones, but it's more complex because the left ear can hear the right speaker and vice versa. We have a basic implementation of virtual surround sound up and running. We're now looking at increasing the size of that sweet spot, which is to say, making the area you need to be in to feel the 3D effect larger, and we're also working to boost the sense of locality. Headphone audio is the current gold standard for 3D audio on PlayStation 5, but we're going to see what we can do to bring virtual surround sound to a similar level, after which we'll start in on setups with more speakers, such as 6-channel surround sound. It's now to the point where some of the PlayStation 5 games in development are extensively using these systems. One of the game demos allows you to toggle between conventional PlayStation 4-style stereo audio and our new 3D audio. I listened with just an ordinary pair of over-the-ear headphones, and wow, I could feel a difference. 3D audio has that dimensional feel to it. Conventional stereo audio feels smashed flat by comparison. The improvement is obvious. So, a big advancement, but have I entered the matrix? Does my brain believe I'm really there, like I was talking about earlier when I explained our target? Well, the answer is no, but you've probably caught on to what's here, namely whose HRTF was being used. It wasn't mine, it was the default HRTF. The audio team analyzed the hundreds that they measured and chose the one that felt closest fit to the total game-playing audience. This shows a piece of the default HRTF on the left and my HRTF on the right. You can see that the general features are much the same.
Не знаю, вот смысл вот делать вот это вот, типа,
With the
все
default
вот,
HRTF, as
все
I
вот это
said,
показывать, потому что это в большей части людям неинтересно. Им интересна цена консоли. Вот, смотрите, видите, уже, ну, человек 50 тысяч, наверное, уже ушло просто потому, что им скучно, потому что вот это никто не будет смотреть, типа, зачем это показывать, типа, характеристики, когда это можно сделать в обычном, конечно, сделать презентацию, там вот это все нужно рассказать. В большей части вот это вот прям в точности все рассказывать не надо, никому это не будет интересно. Типа, я думаю, как-то так.
much difference. I've had a few people describe the PlayStation 5's 3D audio as sounding like a bit better stereo audio. Presumably, they're the ones at the very edges of this diagram, which means what HRTF you're using is key. I'd like everyone to be able to experience what I'm experiencing, but obviously it's not possible to measure the HRTF of every PlayStation user. That means HRTF selection and synthesis are going to be big topics going forward as the Tempest technology matures. At PlayStation 5 launch, we'll be offering a choice of 5 HRTFs. There's a simple test where you pick the one that gives you the best locality. That's just the first step, though. This is an open-ended research topic. Maybe you'll be sending us a photo of your and we'll choose a neural network to pick the closest HRTF in our library. Maybe you'll be sending us a video of your ears and your head, and we'll make a 3D model of them and synthesize the HRTF. Maybe you'll play an audio game to tune your HRTF. We'll be subtly changing it as you play and home in HRTF that gives you the highest score, meaning that it matches you the best. This is a journey we'll all be taking together over the next few years. Ultimately, we're committing to enabling everyone to experience that next level of realism. Hopefully, I've been able to illustrate a bit about our design and decision-making process today and why 5 has the feature set that it does. Now comes the fun part. We get to see how the development community takes advantage of that feature set. I'm hoping for the completely unexpected. Will it come from audio, ray tracing, the capabilities of the SSD, or something else? I guess we'll find out soon enough. Thank you for your time today.
Это все? Нет, за это я кстати, не буду. Что это было? Они сейчас серьезно? Они сейчас тупо серьезно? Охренеть. Получается, это вот этот целый час мы сидели, просто ни хрена не понимали, думали, как даже не покажут консоль саму. Вот трэш, чел пишет трэш. Да, это трэш. Я думал, мы здесь увидим консоль, Ладно, короче, не знаю, что это вообще было. Оставлять ли это дальше, я не знаю. Они не показали ничего вообще. Они чисто показали вот как, что, вот, смотрите, минус 500 000 человек, все, просто ушли они. Минус полляма. О, все, видите, ну как, 120 тысяч, да, ну. Реально, мне не понравилось. Я не увидел здесь ничего такого. Они просто рассказали про систему и вот это, то, что тут у нее будет. А то, что вот, как она будет выглядеть, не показали. Не знаю, я чисто ожидал, что они себе покажут хотя бы хоть. Вот это вот реально вот неинтересно, кому вот это вот, что типа она вот будет выглядеть как вот то же самое, например, типа вот выглядеть она будет. Они здесь тупо этого не показали. Ну что ж, ладно, я думаю завершать. Я хотел видеть вообще ее в свет. Но ничего этого не случилось, как вы понимаете. Все. Мы просто, можно сказать, потратили несколько минут своей жизни впустую. Ладно, всем спасибо. Кстати, завтра, возможно, какой-то стрим будет, может, что-то какой-нибудь грустный скачаю, пройдем. Всем спасибо. Всем пока. До новых встреч. Я ждал больше. Пока.